So, hello everyone. My name is Ariel. I'm happy to see you that you pass the border between the convention center and managed to arrive to the Marriott. Myself, I had a hard time to finding it. It's great to be here in KubeCon, and especially, to see this interest, knowing I'm the last presentation of today, the only one who stops you from going to the party. I hope the party happens. And let's talk about Knative and the security Platypus. Before we talk about Platypus, let's first I'll give you a quick introduction about myself. So my name is Ariel Shuper. I'm working today at Portshift. In Portshift, we're working out with Istio and Service Mesh to create, identity-based runtime protection. I used to work in Aqua Security. I was responsible there for the serverless security solution. A lot of experience working with different serverless environments like AWS Lambda, Azure Function, Google's. And before that, I work in Checkpoint Security, and I was responsible for the public cloud like Amazon, etc. Great. Now, why we're here today? So we want to talk about security. We'll talk about security of serverless, of Knative. And before I start, just a quick poll for the audience. How many in the audience are using today Knative? Great. How many plan to use? Nice. How many which are not using today Knative using Istio? Okay, impressive. And last question, which is a tough one, I know in this conference especially. If I may ask, does anyone in the audience have experience with Lambda functions or Azure or Google? Oh, okay, surprise. Perfect, great. So let's talk about today's hero or the newest presentation. And thank you, Ronnie, sitting in the third floor for selecting it. Does anybody know what this is? Thank you for the answer. So this is a Platypus. So Platypus is sometimes referred to a duck-billed platypus, a semi-aquatic egg-laying mammal. So it's a hybrid combination of a duck and a mammal, or you can consider it as the ancient version of hybrid cloud, something which is both things together. So this is a Platypus, and before we talk about if Knative is a Platypus, and now we know what a Platypus is, let's talk about what serverless is and to see how Knative fits into this environment. So I'm not going to talk about this philosophical question, what's exactly serverless is. I'm just giving, on a rule of thumb, what are the main guidelines of serverless. So serverless usually typically relates to an abstraction of the infrastructure. So no one thinks that serverless runs without servers, but the assumption is that you don't need to worry about those servers. There is some abstraction layer, you don't need to deal with it, you don't need to configure it, you don't need to manage, you write your code, you define your triggers, you define the inputs, the outputs, and from there on, someone else taking care of it. So this, as those of you experienced with Knative or with Kubernetes in general, this is not really the case when you're dealing, with both Kubernetes and Knative, which comes on top of it, and we'll touch in a minute a bit more about Knative. Now, another element of serverless is the fact that it's event-driven or event-based architecture. There is an event, then I only then execute. If there is no event, I don't need to execute. I can scale up, I can scale down, and it's only based on the actual demand and the usage. So this is great, and this is maintained also in Knative. So in this sense, Knative is again great like serverless. And the last pillar is only never pay for idle, only pay for execution time, sub-billing execution time, all those significant cost-saving buzzwords, which are probably relevant where you charge for the compute. If you're running in Kubernetes, you're running in containers, probably less relevant. Could be in some cases where your container is on demand, but in general, they're also less relevant in our space. So when you're asking about serverless and Knative, let's try to understand what Knative is and why did we call it a Platypus. So a quick recap about Knative. So looking at the documentation of Knative, Knative extends Kubernetes to a set of middleware components to build modern container-based applications, or you can look at it as Kubernetes native APIs for deploying serverless-style functions, applications, and containers, or to make it even more simpler, let's call it this way, is the ability to create an event-based architecture for containers. So something that take containers and make them look and feel and behave like serverless functions. Now the main building block in Knatives are build, serving, and eventing. We'll touch more about each one in a minute. Build was replaced lately with Tekton, so it's not depreciated, and now Tekton is the project that leads the CI/CD, the composition of the code into an image that can be used to build container. Serving and eventing are the main building blocks of Knative at the moment. So when you go more deeply into what the serving and the eventing, the main building block of Knative, so serving is the platform which is responsible for scaling up and scaling down, allow you to define a service or a container or anything that you want, and then you also define its primitive, what are the configurations that it will, what trigger will scale up, when it will scale down, what is the maximum, what is the minimum, all the things that you need in order to scale it down. For every container that you deploy, there is a revision. For every revision, create a route, and then you can define the weights, and then obviously the system detect if revision is not being used for a period of time, it will terminate it and it will minimize the deployment. So all in all, it keeps the scaling up and scaling down very, very efficient, and it gives you a lot of flexibility to do a lot of things that you cannot even do today in, I would say, commercial serverless platforms. The eventing is also a very nice architecture. It's the triggering system. It is based on the cloud native cloud events, allow you to define loosely coupled services that you have event source, and you have a consumer and a producer. There's a producer which produces the event, the consumer consumes the event. They don't necessarily need to sit on the same cloud or to share the same cluster. There obviously can be different clouds on different clusters. And then there is a broker, which is a listener, listens, detect those events. When this event happens, triggers the service. And all those elements using both Kubernetes as an underlying technology and can use Istio. Istio is not mandatory. It can simplify other things, but there are other commercial or let's say other options to be used, which create the gateway, the routing, allow you to stitch everything together to make it happen. So all in all, it's a very nice architecture. Looks very promising. The question is this really serverless? It's something which I'm going to touch a little bit later on. Now let's talk about the security side of Knative. So, or why did we call it Platypus, right? So security aspects are not addressed independently in Knative, okay? There is no like direct part or project or anything which addresses it specifically, but it does relies on the underlying technology. So if you're using Kubernetes, it has many security tools, role-based access control, network policies, secrets, and you can see the legendary book that my colleague in Aqua, Liz Rice, wrote about Kubernetes security. And Istio, if using Istio also add its own, additional security tools like encryption, and I think more powerful is the service authentication and authorization, which really allow you to authenticate and authorize who's communicating with who and who triggers those functions, which we'll see is going to be critical in a minute. Now, in order to get better understanding, let's first get more a little bit of a background on the serverless attack surface, or what makes serverless vulnerable, or what are the risks and the potential attacks when you're talking about serverless, and then to see what of it apply, what is relevant for Knative. So when you analyze, when first serverless came out to the market, it was perceived as the most secured cloud service. And the main reason was because it's ephemeral. okay, and it lasts 5 minutes or 10 minutes, depends on the cloud vendor. But when something is ephemeral, it's very hard to construct an attack against it because most attacks require some persistency. Keep in mind that, you're typical when you're trying to attack something, you want to first, penetrate, then you want to find where the sensitive data is or what is worth exfiltrating. And all this work takes some time. So if your entire cycle is limited to 5 minutes, it's very, very hard to do something effective, or it's very, very hard to get into some real thing when it keeps changing all the time. Now, another critical element is that in serverless functions, when you write in public clouds, you have no access to the host file system, so you cannot write anything into it. So even if you find a great, vulnerabilities and you create a great exploit, then you have no way to use it. So in serverless, the classical attacks, are really, it's very hard to exploit them. And there's no fixed network because your function can always come on a different node. There is no guarantee which one is going to come on, and you cannot create a persistent, I would say, networking attack or persistent presentation when you keep changing, your target is keep moving from between different nodes and between different IP addresses. So overall, the threat landscape is very, very small in serverless, but then it took some time until it was discovered there, even in serverless, there are potential security pitfalls. So obviously, the AppSec, the application code, takes a front seat, and all the application code vulnerabilities and potential attacks here become, the first-class citizens. And some manipulation on the cloud infrastructure can also reach and create some potential pitfalls, and those are the main attack vectors when you look about serverless landscape. Let's go a little bit more into the details. So there are a few frameworks that addresses the serverless risk and mitigations. There's the OWASP, the Open Web Application Security Project. So they're doing a lot of work and doing a lot of things. Everything is open on what are the risks of our application. They usually publish their top 10, and they created the top 10 interpretation to serverless. And the Cloud Security Alliance also created a nice framework, the 12 most critical risks for serverless. And those frameworks really analyze what are the risks, why they happen, what are the mitigation, and how you can address them. Let's take a quick look at those frameworks. So having the Cloud Security Association, which personally I think has more accurate and has better knowledge, and they list the 12 different factors. When you kind of try and make it a little bit of an analysis, you can see that some relate to the code. If your function event data injection, if your function doesn't validate your inputs, and instead of event data, I manage to send a malicious input or malicious code, or I can manipulate your function, I can maybe exfiltrate some data, and I'll show you an example of it in a minute. So this is something that it's a problem in your code, in the way you write your application. If you're using insecure third-party dependencies, I can perhaps exploit them. And if you're using secrets or denial of service or business logic validation, all of that is related to the way you wrote your code and the way you're trying to access your sensitive data. If you add on top of it the other parts, you can see it are more related to the cloud infrastructure. So if the authentication doesn't work because you have many functions and each function is trying to access different things, try to do everything, making an authorization mechanism is very hard, so you need to rely on the cloud authorization for that. Insecure deployment configuration or over-privileged function permission, something which happens a lot in public cloud area, that you need to define permissions for every function specifically. Most people try to stitch few things together and bind it and they copy it, and then you end up having over-privileged functions. So this is something which is classical for public clouds. If you look at the OWASP, they put it in a different order, but if you look carefully, pretty much this looks very similar. Those are the same attacks, and again, you can classify them into those two different categories. One category relate to your application code, whether it's the injection or lack of input validation. The other, if using vulnerabilities, sensitive data exposure, cross-site scripting, expression handling, and the other relate to the cloud infrastructure, right? So authentication doesn't work, deployment configuration, you're running something in the wrong way or in the wrong place, wrong location, overprivileged, lack of monitoring or good monitoring, denial of service. I'm not sure exactly where it sits, but this or another, it's a challenge. maybe a small one, because even if you get huge amount of denial of service and get huge amount of execution, then you end up paying $1, $2, because every execution is, of course, is negligible. I'm going to check it in containers. We'll see it might be more relevant, even if there's no associated direct cost to it. Cool. So now, let's take a quick demo, and I'm just going to give you like a quick demo of potential attacks on serverless in public clouds. This demo is based on the OWASP serverless Goat vulnerability app. It's available in GitHub. Let's make a quick jump to it. So this is the repo where you can find it. It's public by the OWASP. They publish it. You can use it. If you want to deploy it, you need to go to AWS. It uses AWS today, probably the most popular serverless step. This is the application. You press deploy. It's going to deploy on your network. Already prepared it. So I already deployed it for you. It's a simple application. Consists of 2 functions, one S3 bucket, one DynamoDB table, and an API gateway. Pretty much, when you use it, you have a simple application. You put in a URL of a Word document. Sorry. Any help? Well, in my screen I see it. Why is it showing you?
Are you trying to submit it? Is that what you're trying to show?
No, yeah, but they don't see it on the screen. Perfect. What did you do?
I just pulled it.
Oh, okay. So let's pull everything. Okay. You see it now? Cool. Now I don't see it. Let me show. Okay. Yes. Great. So it's going to be a little bit challenging. So as I said, this is the GitHub repo. Okay, you can find over here. Right. This tells you the information, deployments. This is the Amazon serverless repository where you can find the serverless Goat. You press on deploy, and it deployed in your environment. When it's deployed, yes, it's going to be challenging to do it both this way. So when you deploy it, you get an application that is having an S3 bucket, have 2 functions, API gateway, and a DynamoDB table. And then, now let's find it. I use this application, whatever, and wait a second. We deployed it. Where is my cursor? Okay, coming. Where is it? Great. This will be a tough one. Perfect. Okay. Cool. So what does it do? What does the application do? You put in the URL of a document, you press enter. I'm going to risk and do it, and then you get the content of this document. Very simple application based on 2 functions, and the content is stored obviously in a database. Okay, great. So now let's see what happens when your function is insecure. So let's say that instead of putting a valid URL, I'm going to temper it a little bit, and we're going to put something different, right? Let's first start with this one. Okay. I'll save the time to know how I know it's a Node.js function, but in general, if it doesn't validate the inputs, then I can get, using a simple command, I can get all the function code. Now, if I'll copy and paste it, and I put it in my ID, I can, of course, sort it out, create it, and see the flow of the function. I even created it for you. So if you copy everything, what?
Well, he's just pointing out, we don't need to read the stuff. He's just saying he can get the code function.
Right. So I can get the code, I put it in my ID, I sort it out, I organize it, and then I can see all the flow of the function. I try to show you it. I even prepared it. I hope I'm going to manage to do it. Yeah. It's not going to work. It's not going to work. All right. Let's try to see if I can close it. Do you see it? Nice. Okay. So when you analyze the code, you can see that I'm using environment variable. I'm calling from the table name. I list the IP, I list the bucket name right over here. I call the environment, and then tell me that there is a reason to check the environment variables, which is great. So I'm going to do now, I'm going to check my environment variables. Okay. All right, a minute. Instead of let's check it out. And I get all the environment variables of the functions. So if you are looking at it carefully, you can see the session token, you can see the access key. Okay, you can see the access key over here, you can see the secret key down there. And those who you work with Amazon know that you have the session token, the access key, the secret key. It's game over, you're gone, you're going in, and you can activate the function. Let's do one more trick, then something new. That's another trick. And again, if you don't secure your inputs, bad things can happen. Right? We'll store this command. And now you get all the database. Okay? Manage to still exfiltrate all the table, get all things. Nothing important here, don't worry, it's only the URLs which I just used. But again, this is an example of if you don't secure your function, I can inject code in, and I can get all this information back to me. Great. So now, let's go back to our presentation. Hopefully you're going to manage to do it. And let's see how much is relevant back to our Knative and see what of that can also be applicable in our case. Yeah, works. Great. Okay, so let's talk about the security angle of Knative. My assumption is, of course, you can question them that you're using your underlying Kubernetes infrastructure configured, you're using role-based access control, using secrets, and if using Istio for eventing, and you configure Istio with traffic rules and authorization policies. I'm saying this is the assumption, it's not a must. You can use Knative even without Istio, but let's assume that this is your assumption, which is a valid option, and let's go back and check, of course, wait. Okay, now I need to get it. All right. Okay, wait a second. That's gonna be, let's try to, I don't know. Okay. Okay, great. So now, if we look back on those serverless code-related risks, we had code injection, vulnerable code, sensitive data, cross-site scripting. I think, you can argue, but I would assume that code injection, again, is relevant even for Knative. You need to validate the inputs of your code, whether it's running on a function or in a container. If you don't validate the inputs, I can definitely do bad things. But vulnerable code, I can argue and say, is not really relevant for Knative. Why? because today the best practice in any container, in any registry, in anything that you do today in containers is to just do this vulnerability scanning, and you can always get it for free from Google, you can get it in many other free sources. And I think it's common best practice to assume that your container images are being scanned. So I would dare to say that vulnerable code is not really an issue in Knative. I would say that sensitive data exposure, if you're using Kubernetes secrets, it's not totally perfect, but you can bridge it. But again, in most of the cases, it's really being taken care of. It's secure. Cross-site scripting when using mutual TLS is not relevant anymore, and exception handling messages is not, again, not a real option or not a real source of information when you're trying to attack containers. If you talk about the cloud infrastructure itself, so again, I think broken authentication, the Kubernetes role-based access control, it can be used very nicely. Insecure deployment configuration, again, this is also relevant. If you deploy your containers in the wrong way, okay, see everything. So if you deploy in the wrong way, then nothing going to help you. Over-privileged permissions, it's really relevant when you're working in a cloud environment. You need to define for every function its own YAML rules, and it's very complex, and then you tend to make mistakes, probably less relevant in containerized environment. Inadequate monitoring and logging, not really the case. If you're using Istio, it's definitely not the case. Denial of service, which is maybe negligible or close to be negligible in regular serverless functions. Here it might be the case. I just point out to a recent Istio security notice that, and we tested it internally. We really saw it really can be an issue that some, if they don't delete connections, you can create flat connections which are very heavy, and then they can really reach. You can reach saturation of your node, and this can be something which can be in containers painful because you can really bring the node, your node down, not just the pod, the entire node can come down, or you cannot get any more CPU, you can block other pods which are running on the same node. This is something which can really be problematic in this case. So in this case, it's a challenge, even though in a regular environment, it might not be a challenge. Now, this is all related to serverless risk. Let's talk a little bit about Knative Security itself. Is Knative secure? So when you look at this diagram, you say, wow, amazing. I have Kubernetes underneath, I have Istio on top. Amazing, it's definitely secure. But when you go more in details of the eventing or both the eventing and the serving, you say, oh, this might have some potential pitfalls. So if we examine the eventing mechanism, then we see that Knative doesn't perform or configure any additional security controls. Now, when we talked about that cloud event are loosely coupled, and we can use different platforms, I can use VMs, I can use containers, I can use SaaS, then I'm saying, whoa, those authentication authorization can really become challenging. Now, if you ask me, okay, so what? What's going to happen? Then think about that if there is unauthorized event subscription, so I can get a lot of information that is not intended to me. I can create false event injection. So I can do some kind of manipulation that can make your life more challenging, I would say, in this sense, to say the least. So now, how do we solve that? And can Istio be our rescue, right? Can we use Istio for this purpose? So, no doubt that Istio can reduce the Knative security concerns. I'm not going to say solve everything, but definitely can reduce. We can use authentication authorization. We can mitigate all those eventing, sourcing concerns. Traffic controls, network policies can also mitigate additional concerns. But then comes the issue that Istio has performance consideration, right? Especially first invocation. We want to create, we listen, we create the listener, there is an event, now we want to trigger, we need to trigger the container, we also need to trigger the proxy. It takes some time. The cold call, which is a challenge in public cloud, it's a much bigger challenge when you're working in Istio. Now, there are techniques which can solve it, you can definitely solve it, you can bypass it, you can avoid scaling to zero, you can do something that will keep your containers, your Envoy up. We see that even in Kubernetes 1.8, this issue is really being taken care of. But again, this is in general. You can argue and say, but I want a real serverless experience. I want something which is real, something that is scaling to zero. I don't want to have my containers up if I don't need them, just to make sure that the next call, the next event will happen. So again, we can argue, we can talk about it, but you need to ask yourself at the end, what do you want? In any way, as I said before, it's not that the Knative is going to replace Lambda function. It's not something to replace. It's a great way to do an event-based, scaled up or scaled down containerized application. And if you look at it in this context, you're saying, you know, maybe perhaps to keep it secure, it's worse for me to do some other mechanism that will not avoid this, because otherwise I can, the loss or the damage can be much bigger. So this is my personal thought. I would love to hear what the guys in the audience think about it. Just to wrap up the talk, because much the time is over. Knative is the Kubernetes serverless platform. Serverless apps has unique risks. Knative is kind of a security Platypus, because some of the risks are not applicable, some of the risks still exist, and some of the risks are really unique to Knative. Using Istio, Knative with Istio can reduce most of those risk challenges. But again, there are obviously performance drawbacks, and you need to balance where you want to be. I'm on time? Perfect. Thank you very much. Any questions, any feedbacks? Would love to hear, please.
This is pretty much completely accurate. This is Evan Anderson on the Knative TOC. So a lot of this stuff is totally accurate. The Istio CNI can help with a little bit of the cold start. If you're interested in the eventing security aspects, issue 1449 and issue 705 in Knative eventing are talking about the security model. It's not done yet. And so yes, today there are a lot of these things, and I think it's great for calling these out. Thank you.
Thank you very much. Anyone else? No need to run. Okay. Thank you everyone for joining. Thank you for coming a long way.